stands for Virtual Environment Navigation in the Underground Sites, and it's the name of a new project at CERN. Its task, to simulate the Large Hadron Collider in virtual reality. Virtual reality is a very powerful visualization technique that allows us to explore CAD models from the inside. By using a head-mounted display and a 3D mouse, the viewer is surrounded by the 3D model and can navigate inside it at will, feeling immersed into it. Head-mounted displays feature stereoscopic vision, providing us with a perception of depth which increases the illusion of being there. LHC designers and engineers can inspect the LHC premises and equipment today, years before the construction has even started, and detect any possible inconsistencies or design fault at an early stage. Previous CERN detectors were visualized through wooden models, usually built on a 1 to 10 scale. These models required a long time to build, were difficult to keep up to date with design changes, and were not inexpensive. A virtual prototype instead is built and updated in a matter of minutes by converting the CAD data to a standard used for virtual reality and allows perfect immersive visualization on a 1-to-1 scale. These sequences have been filmed during real-time fly-throughs of the Venus models of the Atlas, CMS and ALICE detectors. Providing a functional animation of the bridge cranes, we will soon be able to simulate visually the whole assembly sequence of the collider and its detectors. Venus is also preparing territory models of the future surface sites of the LHC pits for an impact study. These models will be used to minimize the impact caused by the LHC construction on the environment. The LHC detectors will be put together by using pre-assembled parts that will be designed and built by hundreds of different institutions and contractors located all over the world. In order to avoid fitting problems at the moment of the final assembly, it is necessary to use a distributed design integration tool. In collaboration with the CRS4 Visualization Center in Sardinia, Venus is developing the ideal integration tool of the future. It is called i3D. The rest of this film is a demo of i3D. Starting from a web browser such as Mosaic or Netscape, we just click on a flight icon, which is a hyperlink to a 3D scene. This triggers the download of the 3D model from the Venus server at CERN. When loading has been completed, the 3D model appears in the new window spawn for i3D. We may resize the window and fly at our will through the virtual world. Navigation can be performed using mouse and keyboard, or more comfortably, with a spacebar. In this example, we are exploring the future premises of the Atlas experiment. These colored bars represent hyperlinks to generic information. Clicking on the white one, we can load the engineering page. The blue one links to a technical drawing of the surface layout. The green one tells us about the experiment's organization. And the red one connects to its schedule. Any object in the scene can be a hyperlink to a picture, a drawing, a text page, a video clip, or any kind of W3 objects. typing H, we can see the hyperlinks bordered in blue wire frame. Some of these hyperlinks will load new virtual worlds. Clicking on the shaft will trigger loading of the experimental area. In this model, almost every object is a hyperlink to more detailed information. If I want to know what this is, I just click on it and the W3 browser tells me it's the muon detector. The Atlas and CMS detectors are being designed. We continue our trip and select the pixel layers which connects us to the CPPM in Marseille. Then the inner detector, which takes us to Nikef. The toroid itself leads to Sakhalin. To reach these Freon tanks. A click on them will take us to a new world, the Cryogenic room. Clicking on the accelerator interface, we can load the tunnel with the LHC equipment. Connecting the spaceball to an object, we can move it around in the environment and observe it from all points of view. Also, by implementing a collision detection algorithm, i3D could be used in future to simulate the assembly phases of LHC and its detectors. The first version of i3D works exclusively on silicon graphics stations, and it will shortly be available on the public domain. Venus intends to develop the concept of i3D further by starting a research project whose task will be to provide the HEP community with a multi-platform web browser, allowing visual integration of the LHC CAD models with all the related technical information available on the web. LHC's virtual prototypes are the largest in the world. Venus will make them available to all of us for access, fly-through, and interaction.
I feel your attraction, it's a strong interaction. You pump me up, yeah, yeah, I feel your charm. You pump me down, tow, tow, I feel so strange. You twerk me top, go, go, on hypercharge. You twerk me bottom, shoot, shoot, on iso spin. You spin me round, 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 yeah. You spin me round, 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 yeah. You spin me round, 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 yeah. I feel your attraction, it's a strong interaction.